I like physics.
Yeah.
I think we're going to go ahead and get started. It's like 8:09. Thank you for coming at this early hour on the last day. That's usually the worst time. I almost asked to get this time switched, but crossing my fingers. Anyway, thanks for being here. I want to make a couple of comments kind of as a preamble to the content here. A couple of things. First of all, kind of a little confession in terms of where some of these thoughts come from. I'm a chemist by training and physical chemistry, and as part of that, I had to take a class in quantum mechanics. And since that time, I've always been bugged by all these weird uses of the word quantum everywhere, right? Quantum coffee, quantum healing, quantum whatever. Until I saw this book called The Quantum Moment. It was a couple of physics and English, and physicist and English professor wrote this book about all the uses of quantum. And after that, I got kind of in this kick to listen on books on tape when I'm walking my dogs in the morning and at night. So I've been listening to the history of quantum physics, kind of an odd topic. But anyway, one of the things that stuck in my mind as kind of an analogy here is the term hidden variables. The hidden variable was used back in the 20s and 30s when they couldn't explain something in the quantum mechanics, so they put in hidden variables. It's kind of like the fudge factor. They figure it out later. And so that's something you'll see coming up here, what a hidden variable is. The other concept is the concept of a mental model. A mental model is how you see the world, a paradigm, a view, point of view, and etc. And I'm introducing that topic, that concept, as a way to view these types of problems. So the overall topic here is looking at fence line monitoring, or what's called the urban industrial interface. And that's the mental model that I'm talking about. But getting a signal in a noisy urban environment when you have an industrial and an urban environment, and how to distinguish between background noise and actual signal from a particular source. So I mentioned so the three ideas we're going to run through is the urban industrial interface, what that's all about, the hidden variable concept, and then very basic keys for implementing a fence line program, an effective fence line program. So general statement here, data collection or measurement at the boundary between industrial sites and residential communities, what I'm calling the urban industrial interface, is becoming, or perhaps now is, an essential tool in industrial and community risk management and risk communication. The urban industrial interface, as I mentioned, is where you have the junction between a residential or school or other types of private entities that are existing right next to industrial entities. And this happens everywhere. I'll show a lot of examples from, everybody's favorite air quality, air pollution location, Los Angeles, but it's indicative of any kind of urbanized industrial location, plus some non-urbanized locations that basically where you have the collision between these two entities. So here's some examples that I've personally been involved in. A new school is built next to a concrete mill and landscape material supply. Concrete mills, as you probably know, emit hexavalent chromium, high risk driver toxicity. A mine and a processing plant next to a small community. Fumigation facility. Those of you on the West Coast, any grapes you get in the wintertime come from Chile, and they're all fumigated with methyl bromide at the Port of Long Beach, using thousands of pounds of methyl bromide. And just a quarter mile away is a huge apartment complex. On the central and east coast, you have New Orleans, and around Maryland area, there are different ports. Same thing happens in those locations. Wastewater plants, we know what that means in terms of odor. Rendering plant next to a new residential community. That's my favorite one. Rendering plant is put 10 miles outside of Sacramento, where I live, in the 1950s, right? It's way out in the boonies. Well, decades later, some developer has the bright idea to put 10,000 homes downwind of this known Stinky source. Go figure. Somebody approved it. Hog feeding barns installed after residential neighborhood is already in place. Again, approved by somebody to do that siting. A semiconductor plant in the middle of a residential area. This was a location in San Jose. And schools next to high volume highways. In California, particularly LA, there's a regulation that you can't put a school within 500 feet of a highway because of the known emission. Just some photos I'm going to run through quickly of some of these examples. This is a rare earth mine south of Las Vegas. If you hear about rare earth mines in the US, this is the place because it's the only mine. There's this and there's China for rare earths. So the small community is very small, like 20 or 30 CHP and Caltrans employees living in trailers. But they were required to put in these fence line high volume monitors because of the radionuclides that are associated with rare earth processing. This is in Sunnyvale, California. The KaiserPermanente plant, it's now gone through several owners, but back in the day it was KaiserPermanente. If anybody has Kaiser Health, this is where it started, back in the 1910s, 1920 era. So this is a big park, thousands of people there, walk and ride their bikes through there every day, next to communities, cement plant, quarry. Lots of dust and other emissions. Oil field surrounded by sensitive receptors. This is a small oil field in downtown LA near USC. You can see all the different types of sensitive receptors. For the South Coast EQMD, a sensitive receptor is basically anybody who isn't inside of a plant, essentially people. LA, again, it's an oil producing area. This is the infamous oil derrick. It's right next to Hollywood High. This is where all the kids of Hollywood stars go to. And this is an example of an oil field, again, in the middle of LA. Closely dense, highly dense oil field surrounded by residential areas. So what happens with all of these? Of course, you have the collision of people who are concerned about emissions and industries that are trying to keep their businesses. This was a petroleum contaminated site. There's a small town called Avala Beach in the central coast of California. At the top of this hill was a bunch of tank farms from 100 years ago, the original precursor to Unocal oil. Pipelines going down the beach, and guess what? They leaked. Surprise. And this is all the contamination. So the town is essentially completely dug up, all that dirt removed, and now it's a beautiful little town, but it was held hostage for decades because of those problems. But during the remediation, we collected samples data continuously because this is the wind direction heading right toward all the receptors in the neighborhood. So over time, what has happened is there's been an evolution in the monitoring approach to things. The original regulatory scheme was to have widely separated air monitoring stations that would collect data for large zones, the metropolitan statistical metropolitan area. I can never remember that acronym, but it's a big swath of land that are separated by different census tracts, right? So there's what, about 15 to 20 here. What do we have since the last few years? Dozens, hundreds, thousands of small sensors that are being placed for local and hyperlocal spatial density. And that's because people are recognizing, it's kind of a push-pull thing. One is the push of the community for more regulation, and then there's a pull from technology that's saying, hey, anybody can have their own monitoring station in their backyard. Quality is a different question, but at least they can get some data. So all of that was the mental model for the urban industrial interface. Talking about the hidden variable, when we do a measurement, is it just a number or is there something more to it? So this definition I've kind of broken down. I found this in a recent book by a famous behavioral economist, Danny Kahneman, if anybody's into that at all. But there's been a lot of big pushes in terms of how to present information. Anyway, measurement consists of using an instrument, which can be a technology instrument or a sensory input, our observations, to assign a value. Now that could be numerical or some other type of value, good or bad, you know, it stinks or something feels not right here on a scale. We all are used to a scale being a numerical scale, 1 to 100, 1 to X, or 0 to X, non-detects are important. So see, to an object or event. An object, of course, is you're measuring, you have a measuring rule, you're measuring a piece of wood or whatever, or an event, which is an upset, an air pollution episode, whatever is happens, or on a continuous basis, just what the background level is. So basically, with that type of a definition, one comes down to if you're doing a measurement, you have industry and you have the urban and the industry, the interface, the two parts are doing a measurement of air quality on a continuous basis by their own observations or by instrumentation. What does that really come down to in terms of people from both aspects understanding the phenomenon of what's going on? And ultimately, behind the numbers that the measurements made or the observations are these two things: risk management and risk communication. Ultimately, the hope, though, is to go to risk mitigation to minimize or reduce the risk. So what is risk all about? There's an injury definition. Risk is the magnitude of the event happening times the probability of it happening. So the magnitude would be how bad is it and times how often it's going to happen. But there's a different definition in the public health world. Risk to an individual, to the public, risk to a person's child, for example, is the hazard plus the outrage. So the hazard is the actual situation, the actual hazard is that odor that they smell or that smoke they see. Is that going to be harmful or is it steam? And then the outrage is how upset they are about it. Do they call their city councilman and say, this guy next door to me is polluting my property? But the result is perception is the reality. So somebody sees that plume and it's got to be bad, or they sense an odor. It's got to be bad. It's chemical. It's got to be bad. And whether or not it's just steam or it's some relatively non-toxic or innocuous chemical that's causing the odor, that perception becomes reality. And that's what really has to be dealt with. So again, this is the environmental health risk equation, breaking this down a little bit. So we talk about risk management and risk communication. What is risk management all about? Mitigation and monitoring the hazard. That would be the site and community monitoring. Getting data and information leading to knowledge that is used in the communication aspect to address the outrage for community outreach. So these two aspects are interactive. It's no good to have a bunch of numbers that shows lots of non-detects at your fence line when you're not communicating that effectively to the community. So what's this all about? I already said this. Risk management and risk communication is basically a combination of a technical problem, the measurement, with a social problem for communication with the receptors. Combination, this is what I'm calling the hidden variable. Yes, all the other talks we've seen this week, we're talking about instrument X has these specifications and this hat length and this detection limit and all of that. And that's all good and fine. But in my opinion, to have an effective overall program, you have to address both aspects. And that's why I'm calling it the hidden variable, because it's not talked about as much. So let's switch gears a little bit, talking about setting up a fence line monitoring program. What are the factors on the path to success? So you got to start with the science and a good technical approach on this. So what are your compounds? What kind of measurement techniques? Actually, that's second technology, but what are your objectives here? You got to start, you got to decide where your goal is, what your goal is. Are you going to collect data just on one particular aspect, or are you going to try and address multiple aspects? How are you going to communicate that? All of these are interactive, essentially. This next step would be technology. That reflects back to your original technical approach. What are you going to measure? How are you going to measure it? It doesn't do anybody any good if you choose a technology that is not sensitive enough to measure what your parameter of interest is. Who are your partners? That would be who are your instrument, who do you partner with to get instruments? Because very few entities have the wherewithal to both design, build an instrument, put it in the field, manage the data, and communicate with the public. So that you have to work as a team for the entire process. So that's what I mean by partners. And then data collection. When I worked at a lab a few years ago, I would talk to my boss about this cool new instrument that GC that would do an analysis in 1 minute. You say, so what? It still takes 20 minutes to reduce the data. Good point. So data collection is the part that is often not thought of enough. And we'll see later on what the result of what the data volume is. Other people have mentioned that. When you have multiple instruments around a large facility, collecting data on a rapid basis, the data management becomes a huge thing. Implementation, not to be ignored, of course. How are your ongoing operations? So everything's set up. Do you have the staff? Do you have the wherewithal to make it run well? Then, of course, all of that ends up the final step of communication to the public, and in parentheses would be the agencies, because typically either it's driven by regulation, so they require reporting to the agency, or it just makes sense to let everybody know. So some key factors on technical approach. I've mentioned objectives, technology. Siting is important. This is one thing that's an issue with all of these small sensors. Don't know where people are putting them. They stick them right on the wall of their house where there's not good airflow, for example. That's an example of poor siting. I had a project where once they put a sensor underneath some branches of a tree. So you think of a pine tree, you know, the branches are coming down. They stuck it way inside because they didn't want anybody hassling with it. Well, guess what? The air doesn't get through there very well. Siting is always something that's important. And if you look at all the guidance, they talk about siting very clearly. Clear guidance. This would be guidance from the agencies. What are they looking for, and what are the types of what elements would they focus on? And then, of course, so you have program design, you lay it down specifically in a public document, and then you have implementation. So here are a list of various aspects in an effective fenceline program. What are your target compounds? Again, kind of being repetitive on that aspect. You have to measure concentrations at low levels that are close enough to your toxicology levels. It doesn't help if you're measuring ppm when health levels are ppb. By the time it gets to ppm, you're really in trouble. Capture high-risk driver emissions. So not only does your system need to collect on a continuous basis, kind of baseline, non-event operations, it needs to be able to capture any kind of rapid event. And I'll show in a minute one of those type events. So you have to be able to have a decent range enough in case there's some type of an upset in the facility while maintaining a decent detection limit for that sensitivity question. And so combination of the two, sometimes it's tricky to reach because you get a super sensitive instrument that tops out at a level that might be saturated during an event, and that doesn't help. Notifications, that would be if you have an event, how long does it take for people to know about it? Both the operators and the public. Recent imperatives from agencies have been that the public needs to be notified very quickly in most situations. And of course, the operator of the system needs to know, because they need to check out to make sure that it's not a false positive, which is almost as bad as a false negative or non-detect, because it gets people all riled up. And once a number goes into someone's head, it stays there. Plus, false positives, of course, start decreasing your credibility of your program. So if you can catch those before they get out and damage those factors, then you increase the confidence of the overall system. Completeness, when you're having a continuous operation, you can't have it go down for many days at a time. And it kind of goes without saying that data quality is pretty darn important. So here's some list of chemical compounds for different types of fence line programs that I've been associated with. You have refineries. Again, in the California experience, the Bay Area district has the Rule 1215 pollutants, and the South Coast district has a Rule 1180 pollutants. Hydrogen sulfide with the star, which means not everybody has to do that, unless they are using HF in that process. I've done a bunch of monitoring the metal industry. It's part of California's toxic air contaminant list. Hexchrome has been a big deal in many areas of the country, particularly in areas associated with metal processing, forges and coatings and that sort of thing. And that's been driving a lot of concern in communities. And again, didn't show any pictures, but there's a city in the LA area, Paramount. Search for Paramount, California, you'll get a ton of hits on hexavalent chromium, because the last 6-7 years, there's been an uproar about all of the metal processing facilities that have been there again for decades. Residential areas have grown up around them. And there's been a high concern about hexchrome because of that proximity. I mean, in some cases, right next door, right across the street from major metal processing. So, and then I mentioned that mine site. That came about from a CEQA risk assessment. And the concerns there are radionuclides, as I mentioned, in terms of the rare earth processing, black carbon as a surrogate for diesel particulate, and PM10 dust, convention, just good old fashioned dust. Still is a regulated substance, the criteria pollutant. Most people are more interested in PM2.5, understandably, but PM10 is still on the books and of a concern in many cases. And I'll show an example later on as well. And then for the mine of rare earth metals, because that's the kind of mine it is. So I was talking about when you're collecting data in an urban environment, there's a lot of competing sources. So there was an interesting article in Science a few years ago, volatile chemical products emerging as largest petrochemical source of urban organic emissions. It kind of goes against the common sense or the nominal perception that it's always the big bad refineries, and of course it's the vehicles. It's all of us, but people usually don't think about all of us as being the problem. So if you look at the pie chart here, volatile chemical products is only 4% of the total pie. In terms of product use, 37 teragrams. That's a lot of grams. But in terms of the VOC emissions, so the emissions from all of those is 38% compared to all the other constituents. That surpasses actually the emissions from refineries and automotives. Highways are an obvious source of competition for detecting our targets. BTEX is always at the top of the list. Everybody in the LA area, for example, knows what benzene is now because of the Aliso Canyon thing that happened, or Porter Ranch. Aliso Canyon is up the coast a few miles from LA, where there was that huge methane leak for a few months, several years ago. Well, the concern wasn't methane, non-toxic, but there was small amounts of benzene there. That's what got all the action. So everybody knows what benzene is now, so it's always at the top of the list. But highways, of course, it's an obvious source, and it depends, though there's differential, the night or early morning, you'll get low wind speeds, and there's dispersion out further. Less mixing in the atmosphere, but during the daytime, the winds shift in this particular location. And so you have 5,000 feet versus 650 feet one time versus the other. So the day-night cycle can be important. And then again, sorry about this California-centric thing. I know everybody's there, but I don't know if you were in one of the keynotes yesterday. Attorney from California talked about the California effect. Sorry, I'm from California. We're pitching all you guys outside. But that's the reality, is that a lot of things that start out there get disseminated. Though actually, the sensor business kind of started in California, but it spread pretty quickly because US EPA, it was back in 2012 when they published the small sensor handbook. So can't blame all that on us. Anyway, warehouse sources, kind of a hidden source here, but in the central huge Los Angeles area, the big urban area, they call it the Inland Empire. When you go east from LA, when you fly into the Ontario airport, for example, you see just dozens and dozens of huge monster warehouses. And we're talking like a quarter mile on each side kind of thing. And guess what come in and out of those? Lots of trucks, diesel trucks. And so all these black spots are warehouse sources of diesel particulate matter. And in the LA area, 70% of the cancer risk comes from diesel exhaust, even though it's a relatively minor constituent of the overall burden of emissions. So those kind of sources have to be managed in terms of your targets and your methodology for measuring what the impact from your target, your facility is to the receptors. So here's one example of a project that Sonoma Tech has done at Maywood, California. My colleague Josette talked about this a little bit yesterday. So here's the little community, but there's tons of these other sites besides highways, but these are all different types of industrial facilities that have the potential to impact this area. These rankings come from a California environmental justice ranking software. So it maps out different areas on the basis of the presence of different types of industries. So I'm not sure, but I'm assuming that there's probably other states that are doing the same kind of thing. But the idea, of course, is to target your effort towards the highest risk areas. So talking about implementation is the third point that I was going to talk about. So we've covered a lot of the target compounds. Now looking at implementation in technology and siting and infrastructure. So these are just some shots of some sites that we're currently involved in. Refinery. So here's the shelter for the open path. The retro is somewhere over here, and the trees are the community. So that's the interface again. A couple of shots of technology, a UP DOS system. There's a shelter. You see the FTIR as a different site. FTIR here. And here, this little white blip here, if you can discern it, that's part of the facility. So when it's close enough that you capture the emissions from the plant at the fence line. Not all locations are like that. Of course, each individual site, you have to manage all of that individually. Implementation, project management, if you have a really cool setup, it doesn't do any good if it's not managed well. So I've been talking about the data collection, data management issue. So you'll see that a big part of multiple boxes here are just dealing with the data. I don't have numbers, but maybe Steve, maybe you'll can chip in on this. My sense is that there are more staff hours put into data management than there are to field operations. Sometimes. there's our data management aspect. And for this, we have the Insight Data Management System. Does all of the functions that are necessary, store and analyze and organize it, do the QA, QC, everything in one package, instead of having to jump from mega Excel spreadsheets to other platforms. This is critical for the next step, which is for communication. So, as mentioned, it's important to have rapid communication to both the facility, to everybody involved, all the stakeholders, facility, the operator, and the community. So rapid response, staff needs to be on call 24/7 in case something happens at 3 in the morning, event notification to everybody involved, and of course, ultimately validated data, because that's what everything will be judged on. So this is a list of a number of projects, refineries that we've incorporated this type of display. I'll show some screenshots of those sites in a minute. Here's an example fence line configuration. So here's the facility with several instruments. There's the beam path that goes across to another part there. First, the beam path you can't see, right? Put that in there, Steve. That's very close. Same thing down here. This is the same shelter looking at another angle. And there's the FTIR that rotates between these two beam lines. So here's the shelter. It switches between this path and that path. Saves a lot of money in terms of having two separate instruments pointing each way separately. So every couple of minutes, it switches from one to the other and collects that data. So here on a real map is our two different pathways. So we utilize this type of approach at multiple sites in order to increase coverage while minimizing or optimizing cost factors. So how are these systems working? So here's an event, a sulfur dioxide plume that happened at one of the sites recently. Looking closely at this, you can see, of course, the peaks hit at different times. So this is basically from south and north in terms of the location of the open paths. So you have to look very closely to discern what the peaks are and everything, but you could tell over time, just a matter of minutes, that the plume start was going from the south towards the north. And of course, you use your met data to correlate with that. And it sort of started impacting the different fence line systems, open path systems as time passed. And this is just a wider spread of one of those. And you can see there are three different systems here. So you see at different locations that the concentrations are different. So that shows at that point in time the plume has moved over the site. So this is important in terms of communication to the public, that the event was captured completely. From start to finish, we saw where it came from, where it was heading, both these real-time data, continuous data points, every 5-minute values correlated with the metadata, shows the wind direction. And that's in a sea of non-detects, very low levels. So the story is that the system works. There's a saying that a story is data with a soul. And so that's what we have here. We have data that is showing that most of the time there's no impacts, but there are events that do happen. And by the way, this also can be shown that the facility where we're monitoring wasn't the source of the impact. That's another big part of the story. It's the other guy. It's always the other guy, but in this case, you can show why. So I'm going to just run through quickly a few, running out of time, sites that we've been monitoring. So this, all of these are screenshots from the public websites that we maintain. So general features are just the refinery location. We'll have the open paths indicated. These are community monitoring sites. This is the MET data. I've chosen benzene again, everybody's favorite compound. This line here is the REL, relative exposure level. Very low numbers there. Background in LA is 0.2 ppb. So we're close to that. The refinery site, multiple open path systems around here. The green lines are each path. Same situation, different location. Highways nearby that need to be accounted for. Two different sites by the same operator. Another site with multiple open path systems. This one, because of the location meteorology, fewer open paths are needed. In community sites, we have the same type of approach that we need to take. Capture the right type of parameters and at sufficient sensitivity and sufficient time resolution along with communication notification aspects. So take out the open path part and take everything and turn that into a point source. So we have these types of measurement methodologies that are employed in these community sites. Everything else ends up being the same. So here's some shots of some community sites. All of these spots, these are actually the low-cost sensors that are implemented, and I think they're covered up. But the previous one at this particular site showed the full implementation of a community site with the regulatory method measurement techniques. Landfill site, the same type of thing. Here's a wastewater treatment example, measuring hydrogen sulfide odor. I've talked about PM10, pretty prosaic substance, but this is the second largest landfill in the country outside of Riverside. And the regulation there came from a CEQA analysis from the 1990s. But they're still doing it anytime they excavate a portion for a new waste cell. 4.3 million cubic yards were removed. And this was truly monitored with a PM10 analyzer operated by solar, remote access, the whole thing. So in the last 2 minutes, I will talk about our technology, our AQ360 decision tool, which is basically a way that one can back calculate from a impact location to where the probable sources are. So in this case, we have here, this is the impact location. Let's say you measure benzene in this case. Where's the height value come from? So you have meteorology data, you have concentration data. Put that into the system, it provides these contours of likely probabilistic contours of where the source may be. And so that could be used for an event, possible event diagnostic, look at where odor complaints originate, respond to community questions, and just for even routine tracking for source contributions. Where's that go? Where are our numbers coming from? So the bottom line here is that here's where we have these types of systems implemented, 270,000 data points per day. So that requires a pretty hefty data management system. 7 facilities of the type that I kind of managed. So all the other stuff. Any questions in our -2 minutes left? Yes.
Quick question. I mean, I think of this more in the facility aspect. So you have refinery systems and all kind of examples. Like you mentioned,
Sure.
River Ranch project, which is more of a community monitoring, purely community monitoring sort of program.
Yeah.
But you had a slide that showed all the inexpensive community monitors around, I guess, adjacent to the facility or around the facility.
Yeah, that was Torrance Refinery.
So was that part of their monitoring program, was to park low-cost sensors out there, or did the community come in and get involved? Did the residents nearby get involved? How did that information come to be in the placement of those sensors in the community? In that case, as an example.
Yeah, in that case, there's a combination of the facility sponsored, essentially, community sites, and that has the full instrumentation package. And those were the green green spots on the one map.
Yeah.
And then the whole mass of all the smaller ones, those were private sensors that were implemented because of people in the community are concerned themselves.
Yeah, it's just, but was it in coordination? Maybe you can say, was it in coordination with the line, for example, with the refinery, or was this independent? Was that
The full regulatory sites were in combination with the fence line system.
Okay.
The small ones, I'm not sure what, if there was any coordination. Are you familiar with that? I know Josette would be.
I would say just talk to us, history of the.
Yeah. Yeah, I can't answer that definitively, but I believe it was, privately initiated, but.
They're certainly not mandated for regulatory application.
Right.
But they show up on the publicly facing website. Or is it not?
Those don't.
Or is that just a slide? Do you have any examples where that happens, where it sort of organically grows and people start popping into one of these?
I don't have any examples of that, but I think, you have a fraction of the community that are pretty interested in all of that, and they'll implement their system on their own motivation. And so that doesn't go into our types of displays. But, you're probably familiar, Blair has their own thing and all that stuff.
No, you answered my question because I saw the image and I was thinking maybe that was part of one of those programs that was publicly facing. I was just kind of curious how that happened.
Yeah, actually,
That just shows where they
I think it was one of the earlier slides that I showed a similar thing. That was from IQ Air.
Oh, okay.
No, yeah, actually that was for the greater LA area. So those are all private individuals, not associated with a site. Okay, thanks, everybody.